we're gonna talk about Thales theorem, which is also known as basic proportionality theorem, commonly named it as BPT. The abbreviation statement is like this: if a line is drawn parallel, to one side of a triangle to intersect the other two sides. I repeat, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Yes, first of all, let us consider a triangle ABC. In triangle ABC, let me draw a line XY which is parallel to BC. XY is parallel to BC. XY is parallel to BC. Then the other two sides are nothing but AB and AC, which is divided in same ratio. What I mean to tell you is AD divided by DB is equals to AE divided by EC. I hope you understood. AD divided by DB, the first half divided by the second half, the first half divided by the second half. It need not be half, but here I have taken somewhat equal to half. So it may be anywhere. The line XY may be anywhere. It may be 1/4 or 3/4 or whatever it is. But the first portion divided by the second portion is equals to first portion divided by the second portion. Instead of half, let us consider to be portion. First portion divided by second portion is equals to first portion divided by second portion. Here we have AD divided by DB is equals to AE by EC. Yes, let us try to solve the theorem. What is given? Given is triangle ABC. Yes, a triangle ABC to be considered. You can name it XYZ or MNP, whatever it is, but I've chosen ABC, the first three alphabets of English. Then coming to the next point, line XY drawn parallel to BC. XY is drawn parallel to BC. Yes, then intersecting other two sides. Yes, the line XY is intersecting the line AB and AC at two different points, that is D and E, where we have mentioned it. And what are we supposed to prove? As we saw earlier, it is like the first portion, AD divided by DB is equals to AE divided by EC. Yes, AD divided by AEEC. Yes, now construction. I'll come to this the part construction later. Let me go with the proof. What are we supposed to do? Here I'm gonna consider the area of triangle of 2 to 3 triangles. So I have noted the formula. Area of triangle is equals to half into base into height, as we know. Now, which triangle am I gonna consider? I'm considering the triangle ADDE. ADE is the triangle what I have chosen, I have considered, and I'm gonna consider another triangle, that is BDEB. BDEB is the other triangle. Considering these two triangles, we need the height of the two triangle. I will draw a line from E perpendicular to AB at M. This is perpendicular, as we know it's 90 degree. See, this perpendicular line is a height of both the triangles, that is ADE. At the same time, it is the height of the triangle BDE, because both have the same base, and one is obtuse triangle, which is the height lies outside the triangle, and the other one is acute angle triangle, where the height lies inside the triangle. So the ME is the common height for ADE, at the same time BDE. I hope you understood. If there is any doubt, please try to comment. I will try to solve your problem or clarify your doubts. Yes, I drew EM perpendicular to the line AB. Then applying the formula area of triangle ADE, I have half into base. Here I consider AD as my base. See, when you say base of the triangle, I can choose AD as the base, or DE is the base, or AE is the base. If AD is the base, EM cannot be the height. EM is the height when you consider AD as the height. When it is DE, we'll have to draw another perpendicular from A. If I consider AE as the base, then I need to draw a perpendicular from D onto AE. So Here I have considered AD as my base, so half into base into height. Height is nothing but EM. Coming to the next triangle, area of triangle BDE. Area of triangle BDE, it's half into base. Base is again BD, and height acts, the same. EM acts as the height. So here EM gets cancelled. If EM and EM are cancelled, EM and EM gets cancelled, and half gets cancelled. What is left is AD divided by BD, where I choose it as equation number 1. Yes, coming to the next part, let me consider another triangle. Before that, let me just try to clear the markings on the triangle. Okay, yes, now let's go with this. Okay, the next point what I am trying to talk about is I'm gonna consider another two triangles. Now I consider AED, this triangle AED. The triangle what I consider is, it's like AED, the triangle. Yes, and another triangle is I choose DEC as my another triangle, DEC, with the black line. We consider this triangle, the red mark triangle over here. And another triangle, I choose the already chosen triangle, which is in blue for now. Yes, so in this case I need an height of the triangle, where I draw DN perpendicular to AC. We mention it in the construction, draw DN perpendicular to AC. Once we are done with it, I go ahead with the area of triangle ADE again, and the other triangle is DEC. For that, according to the formula, half into base into height. Here the base is AE and height is DN. As I told you, both the triangles share the same height because one is obtuse, one is acute, and both have common side. Okay, coming to this point, here we will just go ahead with cancelling half and half. At the same time, DN and DN, what we are left out with is AE by EC. I mark it as equation number 2. Then coming to the third point, here area of triangle BDE, area of triangle BDE and area of triangle DEC are equal. They are equal. What's the reason? The reason is very simple. As both the triangles, BDE, the triangle BDE, I hope you can see the blue shaded triangle, and here the red shaded triangle, yes, both have the same base, which is nothing but DE, same base DE, and they are between the same parallel line, that is XY parallel to BC. So here I choose this to be third equation. The reason, as I explained, the triangles are with same base between same parallel lines, then their areas remain the same, that is equal. So from equation 1, 2 and 3, here I forgot to tell you, here the numerator is ADE, here the numerator is ADE, and from the equation 3 we got to know that area of BDE is equals to area of DEC. Therefore this fraction, that is AD divided by BD, is same as AD divided by BD is same as AE by EC. Yes, from equation 1, 2, 3 we conclude that AD divided by BD is equals to AE by EC. Students, I hope you understood the theorem. If there is any doubt, please try to comment, which will help me to improve my explanation and also to reduce my speed if there is any necessary. Thank you so much.